What's up everyone? Welcome back to my channel. So this is part 2 of the calculus for beginners. So last time we talked about what a limit is and what we need to do if we see a limit problem that has a variable and is approaching or getting close to some values, how we can calculate it and find out the value of the expression. So today we're going to look at another example and see what's going wrong. So in our example, we have the problem. The limit when x is approaching to 2 of the expression x cubed minus 8 all over the quantity x squared plus x minus 6. So before I talk about how we should do it, let's talk about what I noticed and where I found it and what I noticed about it, or anything that's interesting. I found it on Facebook. Sometimes you can actually see the post, some posts on Facebook especially if you join some of the also called groups that is related to mathematics. And in one of the posts, they are giving out something like this: the limit problem. So as always, there are lots of Facebook users who think they know how to do it, so they will just leave their answers in the comment section. One of the guys said this way about the answer of this problem. He claimed that the answer is equal to 0, right? Why? Because let's take a look. If we're using the definition that we just learned from the last video, we're going to substitute the x by 2 to the expression. So on top, the numerator, we now have 2 to the third power minus 8, where 2 to the third power is, of course, 2 times 2 times 2, which is 8. Minus 8 is going to give us 0. So since the numerator is equal to 0, the answer must be 0, right? Let's pause the video and think about it for a second. Are you ready? The answer is no, we cannot do that. We cannot just simply answer it this way. We need to be very careful in our calculation. Why is it not working like this? Or why is the argument incorrect? Here's why. If we're going to follow the idea of limits and use the idea that we have learned from the last video, here's what's gonna happen. If we're going to substitute x by 2, of course, on top, we're going to get 2 to the third power minus 8. But don't forget, we also need to do the substitution to the denominator. What do we get? Well, let's see. We have x squared, where x is 2, so we get 2 squared plus x, which is of course 2, and then minus 6, right? So what do we get? On top, we still get 0. That is no problem. What about the denominator? We get 2 squared, which is 4, plus 2, which is 6, minus 6. What does that give us? We get 0, right? So what does that mean? We get 0 over 0. So what's 0 over 0? This is what we call the indeterminate form. Indeterminate form. What does that mean? It means that it could be any value or anything that we could think of. It doesn't have a fixed result. So how should we do it? We cannot just get 0 over 0 as our answer. It is not going to tell us anything. How should we find out the value then? So in this case, again, this is a video of calculus for beginners. So I'll start from the beginning and we're gonna move on step by step. What are we going to do? Instead of substituting the values in, right away, we can also try to do the following. First, we're going to play around with the algebra, meaning we're now going to factor out the numerator and the denominator respectively in the expression, so that let's see if there's anything we can cancel out. So if we factor out, we get x squared, we get x cubed minus 8 equals x minus 2 times x squared plus 2x plus 4. And again, this can be done by the difference of cube formula. So if you don't remember what that is, go find it out. Then on the denominator, we can also factor out by using the cross product part to get x minus 2 times x plus 3. So you can multiply back in to double check whether we actually factor out correctly or not. So in this case, we see that there's actually something in common between the top and the bottom, and that is x minus 2. So what can we do, or what should we do? We're going to cancel out x minus 2. Then we're going to get the following. Limit of the expression where x is approaching 2. And now the expression is reduced down to x squared minus plus 2x plus 4 over x plus 3. So after we cancel out the x minus 2 on both top and bottom, this is what we have left in the expression. So that now we're going to do the substitution, replace the x by 2 to give us 2 squared plus 2 times x, where x is again just 2. And then we have plus 4 over the denominator x, which is 2, plus 3. And now we can finally finish our calculation. So we get 2 squared, which is 4, plus 2 times 2, which is another 4. So that's 8, plus another 4 at the end, which gives us 12 on top, divided by 2 plus 3, which is 5. And that is our correct answer. Good. So the question is, why can we cancel out x minus 2? Don't we get 0 over 0? Why? What's the reason that makes us allowed to do the cancellation inside of the limit, even we actually get 0 for the term that we're canceling out if we substitute it? Here is why. Now, if we look back to our graph, this time I'm going to make a 2D plane, meaning that we're going to do the graph with both input and output. So let's call the expression be a function f of x, or we can call it y as our dependent variable. And instead of looking at the whole expression, let's take a look of this expression here. X over 2 minus x over 2. So, of course, we know that when x is exactly equal to 2, there's no value because we get 0 over 0. And again, that is what we call the indeterminate form. So, when x is equal to 2, there's no y value, and we are going to leave out the point that is on x equals 2. So graphically, this is what we're going to get. Let's say here is x equals 2. Then we're going to draw a vertical line, x equals 2 here, to keep in mind that when we are graphing this function, the point or the function, when it passes through this vertical line, we have to leave a gap or leave out, because again, there's no y value that can satisfy here. So we know that x cannot be equal to 2 in this case. Good. But how about for any other x? What if x is not equal to 2? Well, if x is not equal to 2, then it is easy. Since x is not equal to 2, x minus 2 is not equal to 0. In other words, we have something non-zero divided by itself. And if we have anything divided by itself, as long as it's not 0, we know that the number divided by itself is always equal to 1. Which means we can now rewrite this function as y equals 1 when x is not equal to 2 and it is undefined or indeterminate. In this case, it doesn't matter, undefined, because we're now in the function. Undefined when x is equal to 2. Good. So if we're going to graph this out, we're going to get, let's say 1 is somewhere here, y equals 1 is here. Then we know that by how we split the function into 2 parts, we have the function looks like this graphically. So as long as it's not on this line, we still need to continue. But how close can we get? Is this close enough? No, right? Because we can see a gap in between. And we still need to fill in that gap there. Now, is this close enough? No. If you can zoom in or make it make your screen larger, you can see that there's still gaps between the blue end point and the line, the vertical line on x equals 2. So how do we graph it? Graph the function mathematically. When we want to exclude some points out, we always say that we need to draw an open circle like this, so that we're saying that that point is not part of the graph of the function. Good. So this is going to give us the graph of the function y equals f of x, which is defined as x minus 2 over x minus 2. Good. So how does that help understanding the concept? Again, do you remember the definition of limit? Limit is saying that we can get as close as possible. Meaning, if we're trying to look at the graph itself, if we're only looking the x components or the input, we should get something like this. So here is the x direction, and let's say 2 is in the center, where let's say here is 1 and here is 3, so that we can see some numbers. Then for this function here, we are going to include everything right here before it hits the 2. How close can it be? Again, arbitrary close, meaning that you can get as close as you want, but not hitting it. Similarly, from the right hand side, we can approach it as close as we want, like this. Then, when we are thinking of the limit of the function right here, we're now talking about any points that are actually inside of the 2 intervals, the purple part. Meaning we can just try to choose any points other than 2. So we can choose our x value be here, we can choose our x value be here, 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 very close to 2, but not 2 itself. Okay, then what happened? Since x is still not equal to 2, it means that if we substitute back into this function, we need to follow our definition. Meaning that since x is not exactly equal to 2, we can simplify that and then give us the value 1. In other words, this is why we're allowed to do the cancellation even if we're trying to take that limit that if we substitute in, we get 0 over 0. So this concept is actually very subtle and very challenging to understand, especially for beginners. But just keep in mind that when we say the limit of some value is approaching or something, we are assuming that that value that we're substituting is actually saying that the variable is very close to the value, but not exactly the value that we're actually replacing by. Okay, and why do we sometimes say that, oh, we can just substitute and get 0? That is just because the error between the actual variable that we have and the number that is approaching to is very small. In other words, the distance between the points that we choose for the variable and the actual value that is given is as close as we want. We can get it as close, like smaller than, let's say, 0.001, or we can even get it even closer, 0.001, 0.0001, and then so on and so forth. So we can get down to whatever we want, 10 to a -7 power, -10 power, anything we want. But keep in mind that this error is always a positive value, meaning that there is always a gap between the points that we choose and the actual values that that's going to substitute in. Okay, then as long as we have this concept here, we can see why we're allowed to just simply do the substitution or replacement of the variable into by the number that we choose. But we are also allowed to do cancellation of fractions, even we're what's so-called supposed to get 0 over 0 case. Okay, so that's it for this video. Thank you for watching. I'll see you guys next time.